Good afternoon and welcome to Florida IP Days Webinar Wednesdays. This is your resident facilitator, Ron Cruz, welcoming you to this afternoon's webinar. Just wanted to say thank you for spending your afternoon, your precious time with us so that you can learn and implement some of the strategies and content that we'll be covering for today. The title for today's webinar is Unlocking the Learning to Build Resilient Learners in Math. So just a quick information, this webinar is designed to provide support, additional content, additional material to prepare for the upcoming regional workshops that IP Day is conducting throughout the state of Florida. As you may know, there's other content that's going to be built into that regional workshop. However, we believe that we need a little bit more support and more time covering the area of fraction squares. So that's really what's going to be the main focus of this webinar. So without further ado, I just want to again introduce myself. My name is Ron Cruz. I'm coordinator of the Caribe Refugee Program here in Hillsborough County, Tampa, Florida. And I'm also a national trainer for GED and Florida IP Day. So this is kind of like sharing you my information if you need to get in touch with me, just in case you have any questions with regards to the material that we're going to be covering for today. Just a quick housekeeping. Just note that your microphones are in mute mode, and so therefore you are on listen only mode. If you have a particular question that you want to ask, please use the Q&A tab. Just clicking on that Q&A tab, a window will open and you can type in and send your questions. June and I will be stopping at different points during this webinar to go over your questions. So please be patient if we haven't gotten to your questions yet. So today's presentation is also recorded. So it will be posted on the IP Day website within 48 hours of this webinar. So let's begin. So our objectives for today is really focusing on using manipulatives. And in this case, we're going to use one particular type of manipulative, which is the fraction squares. We want to focus on understanding the use of the manipulative and model its use, and using manipulative to make your classroom instruction more engaging. So let's go over the agenda. So we're going to talk about why manipulatives are important, fraction squares, what are those, and then we're going to get ourselves familiarized with the fraction squares. Let me just quickly remove the transitions from my slides, if you don't mind. Oh, there is no transition, so I don't know why it's moving up. Okay, let's oh, okay, I see it now. Sorry about that. Apply to all, no transition. Okay, sorry about that. I just I do not know why it's advancing so. Okay, so let's go back to this slide again. So we're going to talk about adding and multiplying fractions using the fraction squares. We're going to do simplifying fractions, comparing all the different things you can do with the fraction squares. And then we're going to talk about other things what else that is not covered within this webinar and what is not covered in the regional workshops. What else can you do with fraction squares? So one thing to keep in mind is that fraction squares are not just to develop fraction knowledge and content. So you're going to find that and figure that out as we go along. And then I'm going to talk about the kind of like the makeup of the regional workshops and see what it's there to expect, because I really, really want you to go there. And if you have the time, your district allows you or your school allows you to go, or to go on travel for trainings and all that, please try to get into these regional workshops, because we are putting a lot of effort, and we've gotten so much great feedback already for the ones that we've already conducted. And lastly, I want to go over some IPDE resources. Okay, so let's talk about manipulatives in history, because manipulatives dates all the way back to ancient times, because people have to keep track of things, during those times where they have to, how many times they had to eat, or how much land they have to cover, or how much time they have to cover in order to get back before the sun goes down and before it gets dark. There's a lot of things that ancient people use to measure time, to measure volume, to measure area, to count. And some of the manipulatives or equipment or tools that they've used in those times are very primitive, but they get the job done. Actually, some of them actually are very, very useful tools, such as the abacus, because a lot of people, or I wouldn't say a lot, but there are some people that still uses the abacus just because of the ingenuity and style and the concept that's being applied when you use it. Now, there's also a counterpart to the abacus in ancient Egyptian times, and they call it a counting board. Counting board, as you can see in the picture right now, is just like a bigger version of a tic-tac-toe. And they divided it into several regions, and each region represents a count or a particular, that's kind of like, think about it like a place value type of thing. And so that as they count certain things, this is the way they keep track of it. And later on, they use this when they started learning about the concept of area. They started using this tool as a multiplication tool as well, because during that time they do not have calculators. So it's way after that the calculators invented. So therefore they have to find a way to do and perform mathematics computations with ease and with accuracy. Now, one thing that's also really cool to share with you is in South America, they use this tool called Kipu. And as you can see in the picture right there, it's a band of strings. And if you look closely, the strings have knots at different places. They represent counts in different place values, and even certain operations being conducted with numbers. So knots that are very close to each other are digits that are very close to each other. And the knots that are further away represent a higher number or a higher place value. It's very interesting to learn how they use their own number system in order to keep track or perform computations during those times. So if you want to read a little bit more about Kipu and the number system that they used, feel free to Google it, because it's when I was looking around and looking for ancient manipulatives, I found this topic very interesting. All right, so who really moved the term manipulatives, or really conceptualized manipulatives as a tool for education, are these two people that you see on the screen. So Froebel and Montessori. So Froebel had done so much stuff. He is the one who introduced the hands-on learning and using experiential learning to really promote mastery of mathematics, and not just mathematics skills, but other subject area skills as well. Maria Montessori took on and built upon Froebel's practice and made it more her own in her own style and delivery. That's how we know all Montessori schools now. They're very popular because of the unique, or I should say, yeah, unique way of how they present content to students. So these two people really move the needle towards pushing for the use of manipulatives in the classroom, which is based on research. It's very powerful because it aids in the retention of knowledge, and it also allows the students to have a hands-on kinesthetic visual type of experience with learning material. So now, during these modern times that we have a modern abacus. You can still buy these abacus. You can actually buy an abacus from Amazon, very inexpensive depending on the style that you want. But you can also go super expensive on the abacus nowadays, depending on the type of material they use. But some people use it for display, but I actually use it for computation. Sometimes it's actually cool to use the abacus and then have people look at me and say, "Ooh, what is he doing? Let me learn how to do that." Something like that, rather than to use a calculator. Calculator can get boring to me sometimes. I'm just kidding. So there's another version of the counting board. Remember the counting board that we looked at during the Egyptian times? Well, people in the Europe started modifying and creating a modern counting board, and you can actually purchase these medieval counting boards. I don't know if you can get them from Amazon, but I started looking them up, and they're actually definitely on Google Store. And then now we have our classroom manipulatives. Most of them are either made out of plastic, wood, rubber, or polyester. So these manipulatives lend themselves very, very useful in the classroom, especially for measurement, for modeling different types of operations. And as you can see, more manipulatives are being developed as we go, especially during the conceptualization of Common Core skills. They figured more manipulatives that apply to different mathematics techniques and skills that we use nowadays. Why is it important? Because that's kind of like how we learn as people. Anything that we learned is we learn in the beginning at a concrete stage where we can observe things, where we can hold, touch, feel, taste them, and the same is true if we apply that same concept or that theory of learning and pretty much learning anything, and apply that into the learning of specific mathematics skills. It's still, going to be very beneficial for our students. That's really how they transition from a low-level type of knowledge or skill, moving them over to more higher-level complex thinking skills. So we start teaching, especially you'll notice this at the early stages of learning, like in the elementary school, people are, the kids are using counters, they're using lots of things that seem to be toys for the students, because that's really the purpose of these things, is for them to have that experience, for them to experience how to count, how to play, how to put things together. In a very observing, in an environment where they can observe, see how things are happening. And as they continue doing those, let's say counting or splitting things up into smaller groups, they start now to have a representation of those skills. And that's when they move on to more representation skills, so that when you get into the early first, second, third grade, most of the things that they learn now, if they don't have access to physical things, the teacher would most of the time draw things or represent or create an analogy or draw a picture of what they're trying to teach. Now, as you go to higher levels, especially in middle school and algebra and geometry and high school trigonometry and all of those types of things, most of those things are really translated into abstract. So abstract thinking, where there's a lot of there's going to be less and less materials or concrete objects to use, and now less and less pictures, but more and more mathematical symbols and more numbers are being portrayed in the examples. So this is really how, in math, how we're going to solidify that learning of the students, that we have to take them through these different stages of learning so that we can ensure retention and mastery. So, according to the National Council of Teachers of Mathematics, there are several skills that are targeted by manipulatives. So, and I'm not just talking about fraction squares because I haven't mentioned and showed you anything about fraction squares yet, but any type or the different types of manipulatives have different purposes. So sometimes some manipulatives are used for sorting, sometimes manipulatives are used for ordering things, which ones go first, second, third, or representing place value or rank. Sometimes we use manipulatives to distinguish patterns such as tangrams and geoboard. Sometimes manipulatives allow us to recognize shapes, such as the geoboard. Again, your tangrams have shapes. You can also purchase or use manipulatives, those geometric nets. So there's a lot of things that you can use manipulatives to allow the students to actually visualize the shape other than what they see drawn on the textbook. Lots of manipulatives that we have nowadays are actually used for measurement. So we have weighing scales, rulers, tape measure, and things like that. And then learning how to count in base 10, comprehending mathematical operations, specifically addition and multiplication, and then looking at different relationships of operations. That's something that I really want to touch on in this webinar today, because this is something that teachers rarely show. Showing what's the relationship between addition and multiplication, or what's the relationship between multiplication and area of an object. So things like that is really important to show and explain to the students, so that as you move on to a different topic of math, they have that lingering idea that that the foundational skill is being used as a springboard to higher levels of math. Exploring, describing spatial relationships now with technology, this is really enhanced. Different types of symmetry. So, and it doesn't have to be commercially purchased manipulatives. You can make your own manipulatives. You can go onto the internet and download like a black line of, let's say, geometric nets, or you don't even have to do that. You can just use and take a piece of paper and fold it into half to show symmetry. Sometimes some teachers use art. Sometimes teachers use everyday objects as manipulatives. So there's really nothing that's preventing you from, or there's really nothing limiting you in what we call manipulatives. Anything that you use in your classroom to promote a mathematical thinking can be considered as a mathematics manipulative. So we're talking about that, experimenting, problem solving. So these are the things that I think we are going to cover today. And if today is not enough, we're in the regional workshops, we are also covering a lot of them, especially problem solving, which is really the highlight of standardized testing. Okay, so without further ado, I want to introduce you to fraction squares. So fraction squares is what you see, the image that you see right in front of you on the screen. So what they are, they're colored squares, okay? And each colored square, and there's going to be different colors as you see. You got red, you got purple, green, pink, yellow. So the colors represent different things, and you can probably see them right now. Like, I notice all of the halves are pink, and all of the thirds are in orange. So you're going to notice that because these, when you first purchase a fraction square, or if you look at a fraction square template online, they're delineated, or they're differentiated by color. And so therefore that allows the student to kind of memorize what shape or what type of fraction they're working with. So let's introduce to our first basic piece of the fraction square set. So a set could range between 48 to 56 pieces of tiles. So I want to introduce you to the different tiles that you're going to be encountering when you open up your own set of fraction squares. And I just want to let you know that I'm very, very excited to announce that for every person that attends our regional workshops, you will get to take home with you your own set of fraction squares. So if you have not signed up for any of the IP Day workshops, regional workshops that are happening throughout the state, please go to the IP Day website and sign up for the one that's closest to you, because that's your chance to actually score a free fraction square set for you, so you can start using and implementing these strategies. If you cannot, I still have a solution for you, so just tune in and I'll share with you some of the other materials that I have for you in this webinar. So the first set is the whole. So it's just one big piece, no divisions. Some fraction squares have markings, just like what you see in front of you. There's a 1. Some fraction squares are just plain. They don't have any markings on them, so the student have to either memorize the color or memorize the size of a particular piece so that they know what piece they're using. So a lot of people think, oh, the whole is not useful because it's a whole, it's not cut up anymore. Actually, this is actually the most important piece of your fraction squares, because you're going to be using this to compare with other pieces. So please keep that whole handy and don't let your students ignore that piece when they open up their fraction squares. So let's take the whole and cut it up into halves. So that makes up your halves. And then we take the whole and you cut it into 3 equal parts. That will give you 1/3 apiece, and we'll call them thirds. So the next 2 sets of the next 2 squares you're going to encounter in your set is the pink square. And keep in mind, the pink square is divided into 2 equal parts, and they're each half. And they are, you know, they're no longer a square when you piece them apart. They're now a rectangle. So the thirds, again, is the same as the half. It's just a whole cut into 3 equal parts. We'll call them a third. Once they're pieced apart, they're no longer a square. They are now called rectangles. So just make sure that you clarify the use of vocabulary for your students, and also be careful with using what type of vocabulary for each particular piece of the fraction squares that you're using. So when you go in and divide the whole, the next 2 sets of rectangles you're going to see are the quarters and the fifths. So the quarters, just like the halves and the thirds, the quarters are just a whole piece, just like the red piece, cut into 4 equal parts. The fifths are the whole piece cut into 5 equal parts. And then it's also good to know, okay, ask the students, okay, so if I have quarters, how many quarters are in the set? And they'll say, okay, well, count how many yellows do you have? And they'll say, well, there's 4, so there's 4 quarters, and 4 quarters make a whole. Okay, then practice the same type of thinking and also description with fifths. So look at your sets, how many fifths do you have? And they'll say, well, there's 5 fifths in the whole set. So therefore, if we put them together, piece all the 5 fifths together, they form exactly the same size as the whole, and therefore there's 5 pieces or 5 fifths to a whole. And then you're going to get the next 2 pieces, the blue. There are 2 blues. there is a light blue, or I would say, I wouldn't say it's baby blue. So let's just say it called light blue or a little bit close to teal. And then you have your dark blue or navy blue, which is your 1/8. So the same concept, the same type of reasoning. If I have a whole and I cut it into 6 equal parts, then I'll have 6, and they're colored differently so that we can differentiate them from the other pieces. And then 6 with a TH make up a whole. Same is true with the 8s. That's just a whole piece cut into 8 pieces. So when you put together the 8/8, that still makes up the same exact square as the whole. Now we go to tenths. Same concept, practice with thinking with your students. You take the whole piece, cut it into 10 equal parts, then you'll have tenths, and then take the whole piece, and if you cut it into 12 equal parts, you'll have twelfths, and 12 pieces of twelfths put together to make up a square makes a whole. So I just took you to that practice of describing, talking about the different types of fractions, pieces that make up a fraction square, and relating them again to the whole so that they can see, okay, oh, I see they're the same size, it's just a different color. The one to the left is just a whole piece, and the one to the right is just cut up into smaller pieces and cut up into equal-sized smaller pieces. Sometimes students find it very intuitively, and you would, if you let them play around with these manipulatives, you'll find them, rather than putting these manipulatives side by side to compare the size or the area, they would put it on top of each other. So that's a little tip right there for you, that you can use the whole as your foreground, and then you can put the manipulatives or the smaller pieces on top of the whole to compare the sizes. So that's something that what I found my students love doing, is they'll stack up the fraction pieces so that they can easily compare, accurately compare whether they have a whole or not. So let's start practicing with some operations. So what you see in front of you are 3 sets or 3 squares, okay? Each square are made up of rectangles, smaller pieces of rectangles. They're not all equally sized, okay? So let's talk about the first square on the left, which is made up of pink and yellow pieces, okay? So if I were to ask you, okay, so can we write an equation describing this particular square? And then you would model to the student, okay, so what pieces do we have? I have a 1/2 piece, a 1/4, and another 1/4 piece. So if I piece them together, I'm trying to find the area of the entire piece, which makes up a whole or a whole square. We can write 1/2 plus 1/4 plus 1/4 equals to 1 whole. Now, students will easily catch up. You keep saying, okay, I need 2 of the 4/4 pieces, or I need 2/4. So then they can easily make that transition to thinking that 2 1/4 pieces can be written as or rewritten as 2/4, just like the equation that I'm showing you right now at the bottom. Okay, so now that we've practiced this one time, now this time I'm going to give you a few seconds to kind of jot down what would be the equations for the other 2 squares, okay? So think about what pieces you're using, okay? Write them all, on a scrap piece of paper or in a sticky note that's handy, and then make an equation equal to 1. And the reason why we're equating it to 1 is because we started off with a whole piece as equal to 1 whole. So therefore, we're always equating it to a square that is equal to an area of 1, okay? So let's look at the second square. Do you have something similar to what I have? For some of you that are advanced thinker, or for some of your students that are a little bit more advanced thinking, they could already simplify that equation to 2/3 plus 2/6 equals 1. Because I have two pieces of the thirds and two pieces of the six, I can easily rewrite that as a 2/3 plus 2/6 equals 1. Following the same thinking process, we're going to write an equation for the third square. So I see a 1/2 piece and 4 1/8 pieces. So I have here my equation. I have 1/2, 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. So you can write 1/8 4 times, laying out all of the different pieces of the fraction tiles that you've used. Or some of your students that are, again, advanced thinking, they can already simplify or shorten the addition equation into 1/2 plus 4/8. Either way is fine. There is value in writing them in expanded form and writing them in simplified form. So the equations that you see on the second row, the equations that you see at the top are the equations that are written in expanded form, and the equations that you see at the bottom are your equations that are written in more simplified form. Okay, so let's talk about, again, fraction sums that equal to a whole. So again, just like I said, students may overlap the fractions on top of the one whole piece in order to see whether they're exactly equal to one whole, just like what I'm going to show you right now. So I have three whole pieces of squares here, and I can overlap the first one that we have and see how it exactly overlaps with no edges or things like that. And it's exactly the same size as the one, as the one whole. The second example, again, overlapping it on top of the one square. And on the third example, again, overlapping the 1/2 plus the 4/8 on top, and they should equal or have the same size. So one thing that you can also talk about to the student is that the orientation of these rectangles. I always tell them you must keep all of your rectangles upright where you can actually read your fractions rather than side by side or like sideways. Okay, because of the fact that it gives them a technique on how to put them together quickly. Because as you can see, some students might have the 1/6 and the 1/6 sideways. And if you put it together with the 1/3, it will not create a hole. It will create kind of like an L shape. And they might think, oh, it does not equal this shape, or it's not a congruent shape as the whole, so therefore they don't have an equal area. Well, that's not necessarily true. So really how we orient these fraction tiles, upright rectangles, really matters, okay? It might work for certain tiles, like the 1/8. I think you can stack up the 1/8 4 times to make up a half. But I don't know if they will work for the other tiles. So then as you show these 3 examples to your students, they'll figure out, oh, okay, so different combinations of tiles, different combinations of fractions can make up a whole. So then tell them and give them an opportunity to play around. Okay, so what other combinations can you come up with that will add up to a whole? And again, they're going to be limited to the fractions they're going to use. They're only going to have to use the fractions that are represented by the fraction squares. So they cannot use 1/18 or 1/9 or 1/7 because those numbers are not part of the set of fraction squares they're using or they have in the set. So give your students an opportunity to come up with different types of squares and then have them take a picture or have them check it with the whole piece, overlap it with the whole, or put it side by side with a whole and see if and have them evaluate whether the 2 squares have the same area. Okay, so now we're going to cover a little bit of multiplication. So multiplication of fractions can also be taught using fraction squares. Now, it's going to be tricky when you're multiplying a unit fraction to a unit fraction. So with fraction squares, you're only limited to multiplying unit fractions by a whole number, such as the examples that you see. Again, all of the 4 examples that you see up here on your screen are all products equal to 1. So very similar to the exercise that we did when we were describing the fractions at the beginning, where we have, I have 2 of 1/2 pieces that makes a whole. So if I put the fractions of the same color together and make up a whole piece or equal to a size or congruent to a whole piece, then therefore I have made up my product equation. So I need 4 pieces of the fourths to make up a whole, 3 pieces of the third to make up a whole, 5 pieces of the fifths to make up a whole. And you can continue doing this and modeling the multiplication equation to your students as you use all of the fraction squares. At this point, I am going to stop for a moment because I think we've covered quite a bit of material so far. I'm going to check in with our Director of Florida IPDAY, Ms. June Rawl, to see if we have any questions.
No questions, Ron, just some nice comments of your interpretation.
Thank you very much, June. So we really appreciate, even if you don't have any questions, feel free to type in your comments because we do read all of these comments and take them into consideration as we design future webinars and how we can further improve or give, if ever we're going to do a part 2 of this webinar, we usually look at the people's feedback so that we can enhance them and take your and have your take into these webinars into consideration. So moving on, let's go on to multiplying again of fractions, moving on to the 6ths and the 8ths. So now what you have right now is very similar to the previous slides. Again, in the multiplication of fractions, students will realize very quickly that all I'm doing is collecting all of the pieces that are the same color and size and arranging them like a puzzle to be congruent to the whole piece, which is the red piece. Okay, so notice that the students will start forming that pattern, and then once they form that pattern in their minds and also visually, then they realize that you can move on into representational or abstract thinking by saying, okay, so if I have a whole number, or let's say a numerator of 6 and a denominator of 6, that concept of cancellation, which students love to do, like, it's a 6/6, let's cancel 6 to 6 to make up a 1. This is what's really happening in the real world. That cancellation process is showing on an abstract sense that these 2 numbers represent a whole. Okay? So that the process of cancellation is just not, it doesn't get reduced to a simple procedure or algorithm. It actually means something to the students, and students actually see what's happening in the real world as they realize that as they realize the operations on the fractions. So now, of course, as I increase the number beyond the denominator, what happens now to my fraction? Well, therefore, let's say, for example, I took 7 pieces, or let's say I have 7 pieces of the 1/6. So intuitively, the students will say, well, I have an extra piece here and I can't put it anywhere or arrange it in any way that it would look like a square or it will be congruent to the whole piece. So therefore, I can already conclude that if I multiply 7 times 1/6, I'm going to come up with a fraction that is greater than 1, or that is greater than 1 whole, because you have exceeded the area of your whole square. Moving on, let's talk about this time products and sums. So sometimes I would ask my students, okay, now that you're used to a square, now we can move on to rectangles, because not everything in the real world that you will encounter is going to be equal to one whole. Okay, so we use the technique of comparing it to a whole to start the foundational knowledge of fractions with your students. But then as they gain proficiency, now you want to move them on to from congruent squares to congruent rectangles. The reason is that not everything that's in the real world exists in perfect squares, okay? So here are just some examples. So let's say I want you to perform the indicated operation, but I don't want you to write it down. I want you to actually use your fraction pieces. And then what I want you to do, once you've put together these pieces, I want you to use another set of fraction pieces that you still have to verify or to identify the sum of the fraction. So let me model it first before, I know there's a lot of words and explanations that I just mentioned there. So let's take, I have 1/4 plus 2/8 plus 2/8. So here's the representation of that fraction rectangle that I've just put together. So I have a piece of the 1/4, and 2 pieces of 1/8, and then I repeated it again, 2 pieces of the 1/8. So now I have this piece, and I'm going to look into the rest of my fraction squares pieces and see, can I come up with another rectangle that is congruent to these pieces that I just put together? Well, of course, I can come up with these yellows. So once I put these two rectangles on top of each other, they will see that these two rectangles are congruent. Okay, so that means they have the same area that they covered. The height is the same, the width is the same. So on the left side, I have 1/4 plus 2/8 plus 2/8, or you can even expand that even further if you want. And then on the right, I have 3 pieces of the fourths, or 3/4. So therefore, we can say once they've verified that, that's the reason why when we add all of the numbers, 1/4, 2/8 plus 2/8, you come up with 3/4, because in the real world, this is how they are represented, or that's really what's happening. So let's try it again on 1/3 plus 2/6. So I got a 1/3 piece and a 1/6, and 2 pieces of the 1/6 piece, and I form a rectangle, right? Then I'm going to go back to my set of squares. Can I come up with a different rectangle to kind of like simplify the sum of these pieces? So I can come up with, there will be no other combinations of pieces in your fraction squares that would match or would be congruent to the first rectangle other than 2 1/3 pieces, or otherwise known as 2/3. So this exercise practices the students in looking at fractions, adding fractions, but also examining congruence in areas of rectangles. Okay? So you're actually teaching 2 different types of skills, and maybe even more as you go and explain and as they do the operations. But this really shows the students that what you're doing on paper has some real life representation. So this time let's practice this with the multiplication this time. So let's say I only have 9 pieces of the 12s. Keep in mind, if I have 12 pieces of 12s, I make up a whole. But in this case, I'm going to change that up. I'm going to use 9. Let's say I have 9 pieces of the 12. So that definitely tells the student, oh, I will not come up with a whole square, so therefore I have to come up with somewhat of a rectangle to come up to represent this product. And that's true. They can arrange the squares again, keeping the rectangles upright. They can arrange the rectangles upright like this. Okay. Again, it will be quite a challenge if you're doing it sideways. So, but it can be done. So now you have 9/12, right? Well, what is 9/12 equal to? So pretty much reducing that fraction to the simplest form. Well, I'm going to go and come up to my the other pieces of my fraction square and see what else would match. What other pieces would exactly match this rectangle, meaning I'll be able to construct a congruent rectangle with a different set of pieces. Well, there's no other set that would come up equal to this other than 3 pieces of the fourths. So now I can make the relationship as if I multiply 9/12, I'm coming up with 3/4. You can easily explain the process of how cancellation works here for some of your advanced students, but for your low-level students, this representation makes a whole lot of difference. Just then just telling them, okay, when you're multiplying a whole number by a fraction, put the 9 over the 1 and then multiply across. Okay, so that makes, this way of presenting multiplication of fractions is much more meaningful than it is telling them the steps on how to multiply fractions by giving the steps on what to do with the numerator and the denominator. Okay, so let's do the same thing for the 6/10. So if I only had 6 pieces of the tenths, that's understood to me that I'm not going to make a full square. I can verify that using my whole piece. Okay, and then I'm going to go again into my set of fraction tiles and see what other pieces can make up the same exact area. And they'll quickly realize the pattern here. So now I'm going to come up with 1/5. 3 1/5, which is equal to 3/5, which is really the answer to our multiplication equation. So hopefully you are kind of like getting the process of how I'm explaining this. Eventually, I mean, the challenge with the webinar is that I can't really show you how I'm manipulating it. So really, you're only looking at a PowerPoint presentation. But hopefully, some of you that did their homework in advance looked into the workbook and saw that there was a fraction tiles, fraction squares template there that they can cut up so that they can just participate in this webinar by actually manipulating the pieces. You can do that later. Just keep in mind, this webinar is recorded and you'll have access to this after 48 hours. So now let's go on to continuing with simplifying fractions. If I have 6/12 and 4 6s, your students will easily notice that we have, I'm sorry, I just advanced it quickly. Will easily notice that there are other pieces or combinations of fraction squares that would work. Moving on, we can also use fraction squares to compare fractions. So in this case, if I have a set of 2 fractions, 2/8 and 2/6, and I wanted to compare them using inequality symbols, so then what you're going to ask your students is you go ahead and put together the shape, put together the rectangle, or even it might even resemble a square, I don't know, depending on the examples you pick, and then compare the area of those rectangles to see if they are either one is greater than the other, or they're equal in area, or one is less than the other. So in this case, I will model 2/8 to the left with the darker blue, and then 2/6 to the right, which is your lighter blue color. And you can clearly see here that the one to the right covers a bigger area than the one to the left. So then, therefore, we can say that 2/6 is greater than 2/8, or 2/8 is less than 2/6. Now let's move on to the next example. For example, I have the 2/8 plus 2/6, and I'm comparing it with 1/2. Again, in here, for some of you, you might look at it, oh, they are so close, right? I don't know which one's bigger. So you can take that pink piece and put it on top of the blue, the combined blue pieces, the light and the dark blue, and you can clearly see that the combination of the blues are cover a greater area than the pink. So therefore, we can say that 2/8 plus 2/6 is greater than 1/2. So now there's a real value here. So take it slow when you're doing this with your students. Make sure that you're explaining that when you're comparing fractions, what you're actually doing is you're not just comparing the numbers, because you can't just compare numerator, and denominator. When you're comparing fractions, what you're trying to do is you're actually comparing areas, areas of rectangle or areas of whatever shape. And you're comparing to determine which fraction is greater. So show that to the students, that the process, that's what's happening with the numbers, and all of the algorithms that we're showing you when we're working with just plain numbers has a representation in the real world using fraction squares. Moving on to the bottom left, 1/2 and 2/3, if we have to compare those, then we take those 1/2 and 2 of the 1/3 pieces, and again, compare. Side by side, by inspection, some of your students will see, oh, I see the orange area is covering more area than the one in the pink. If they're not quite sure, again, you can take your pink piece and put it on top of the orange, or take the 2 orange pieces on top of the pink and see which one covers more area to determine that 1/2 is less than 2/3. And last example here. So if you have 1/2 and you're trying to compare it with the sum of 1/3 and 1/4, you'll take the fraction pieces of 1/2 and compare it with the combined area of 1/3 and 1/4. This one gets really, really close now. So again, if your students are confused or they can't decide just by inspection, they can take that orange piece, they can take the pink piece and put it on top to really judge that 1/2 is less than 1/3 and 1/4 combined. So this is really, as you're explaining, perfect opportunity for you to use your mathematics vocabulary, using the word sum and product, greater than, less than, equal, things like that. This is a perfect opportunity for your students to practice that vocabulary when they're describing the relationship between two numbers. Just like I said, using fraction squares, there are a lot of things that you can show. You can not only show addition, multiplication of fractions. We did simplifying fractions. We did comparing fractions. Equivalent fractions also is another way, another concept we've developed. And then in geometry, we're looking in congruence, because if we're comparing them with other fraction pieces or with the whole piece or the square piece that's red, then that's really looking into congruence and showing them what that concept means, and then looking into areas as well of rectangles. So not just areas of squares, but also areas of rectangles. Now, as your students gain more proficiency with the fraction squares, they will no longer form squares. Sometimes they would form composite shapes, or an L shape, or a T shape, or whatever shape. As they get more proficient with the use of fraction squared, they get so used to these unit fractions that no matter what shape they form, they know exactly what that sum would be or what the total area would be. During our workshops, regional workshop, we will be using fraction squares to really model how to solve word problems. So if you have no plans of attending, please change your mind. Start looking into your calendars and start looking at the closest regional workshop if they is conducting our regional workshops. Please sign up. So there are other things that manipulatives are improving as we go along. Verbalization, just like what I mentioned and I highlighted earlier, verbalizing the mathematical thinking is really important. And I think I modeled that consistently throughout this webinar. And then allowing the students to discuss different ideas amongst themselves, really allowing that use of vocabulary within between students, relating it to real world, working in collaboration with each other, thinking divergently. So really, it doesn't have to be a square. It can be a rectangle. It could be an L, or it could be any type of composite shape. Expressing problems and solutions in different ways. So some of students may be imagining and thinking about these fraction squares or fractions tiles when working word problems, because now they have a clear visual image of what's happening in the real world when you're adding, when you're multiplying, and when you're simplifying fractions. Making presentations, it really does promote ownership in the learning experience when students discover things on their own rather than you telling them that 1/2 plus 1/2 equals 1 whole, or you add the numerators and keep the denominator the same. That type of explanation is kind of like Chinese or a foreign language to a lot of students. But if you use manipulatives side by side with your explanation, not only do they see the reality of the mathematics, they're also developing certain type of ownership as they discover things on their own. It really builds confidence with your students. Eventually, you want to take away these manipulatives from the hands of your students because they won't be able to use manipulatives when they take the test. The true purpose of manipulatives is really to strengthen that foundational mathematics skills that the students have. If they do not have their foundational skills, if they are struggling with fractions and you've tried everything, maybe testing out the use of fraction squares might improve their mathematical reasoning in the area of fractions quickly or differently. Okay, so there's lots of research with the use of manipulatives. I wish you would try them out. I've developed a workbook to go along with the PowerPoint slides that you can download quickly from the IPDAY website. So I'm going to exit here quickly and just show you where it is on the from the IPDAY website. If you go into, I think it's under ABE webinars. Yes. So in here, if you click on under webinars, click on the webinar itself, the presentation and the activity book is right here already at the bottom of the screen. And then on the bottom right, you're going to see a link there after 48 hours, or actually an image or a video clip that you can click on and then review this webinar again. You can even play this webinar with your students and learn fraction squares with your student and so on and so forth. But I want to take a little bit of time to just show you that activity book because I've got lots of things that I included there, some guiding questions, some of the visuals that I used here, and most importantly, ta-da, the black line. So I'm giving you a black line master. So if just in case you couldn't get your hands on the manipulative, or purchase one and hasn't arrived and you already want to teach the lesson, you can print this sheet, make it or copy it on a cardstock, and then cut it up into smaller pieces. Or you can even assign and give this to your students, have them cut it up so to save time as homework, and then they bring the pieces to school the next day. Do not forget to give them a Ziploc bag or a container or an envelope to put these pieces in so that they don't lose the pieces. So I gave you a black and white and a colored black line just in case you don't have access to a color printer or a color copy machine. Then you can use the black line for the black and white pieces. Keep in mind that the black line pieces are split slightly different than your colored pieces. So it's going to get some getting used to or practice with the black and white black line. All of the activities and examples that we did in this webinar, I created kind of like a worksheet for you so that you can play this webinar and your students can play along and write the equations or model or draw the fraction squares. So there's fraction mats all over here, and so that you can do the same exact activities with your students to develop their understanding of fractions. So hopefully that's going to be useful to you. And then again, if you haven't signed up for an IPDAY webinar, please go into the IPDAY website, go to the event calendar to find out which regions are going to be hosting our webinar. So these are some of the regions that we have already in line to do webinars. So we're pretty much covering the entire state for this. So there should be something that's close or within an hour of travel from your district. These are some of the things that you're going to get. Not only will you get a lot more manipulative, a free set of manipulatives, you will also have a set of PowerPoint slides, all of the word problems, the matrices that were given out. We'll also have vocabulary and games. We're incorporated games into our workshop so much because we know our students love to play games, especially if we teach ABE at night. It's good to get them up and moving. Okay, I'm going to advance the slide now. So again, please tune in for other webinar Wednesdays because we have other webinars that support other parts of the regional workshop. So please stay tuned. And again, there's lots and lots of resources that are available there for IP Day. June, I just want to quickly check. Do we have any burning questions before we move on and close this webinar?
No, just a lot of great comments about they wish that they had those manipulatives when they were learning fractions and lots of great applause. So let's get right to the feedback.
All right, so we want to hear what you think. Please share us your feedback. So please complete the quick survey. The survey will pop up on your screen and there are going to be few questions that I need you to click, and we would like to get your feedback. So I'm going to pause for a few seconds to let you do that. And again, I really, truly appreciate the time that you spend to tune in live during a webinar, because we know live webinars and being on the moment has its benefits as compared to listening to a recorded one. With that said, I wanted to say thank you for all of you for participating this afternoon. Please stay tuned to our future webinar Wednesdays. This is Ron Cruz saying goodbye.